Is I greater than or less than 0? It's an interesting question, and it's my hope that by the end of this video, you will be able to not only understand this question, but also answer it confidently and be able to take away the beauty of imaginary numbers. Let's take a step back. Natural numbers are basic positive numbers such as 1, 2, 3, 11, and 1000, and they were used by early humans to do their basic everyday chores like counting their animals and plants. At this point, many countries did not use negative numbers and 0 because they did not understand why they would use it. What is a negative number of sheep? Why would you use a number that represents nothing? These were the questions that these countries had. But as the human civilization progressed, things like money systems and the concept of debt made the use of integers clear. Soon people started using ratios such as 3/2, and it led to the rise of rational numbers. Then, advanced math gave rise to irrational numbers because they realized that there were some gaps in the number line. All these numbers are called real numbers, and they entirely fill up the number line. This diagram shows the relationship between each type of number. As you can see, the left side is all real numbers, and on the right side there's a new type of number called the imaginary numbers. So what exactly are imaginary numbers? So I think of them as keeping algebra intact, but that might sound a little bit vague, but don't worry, later in this video this will start to make sense a little bit more. So to really understand these numbers, let's take an example. F of x is equal to x squared plus 1. So if we solve for when f of x is equal to 0, we get that x is equal to plus or minus the square root of negative 1. So what does the square root of a negative number mean? Does that mean no solution? According to the graph of f of x, it looks like the graph never touches y equals 0. To understand this, let's look at the fundamental theorem of algebra. It says that a polynomial function will have as many roots as its highest degree. In other words, f of x must have 2 roots because our highest degree is 2. This means that plus or minus the square root of negative 1 must be our 2 roots. But what does this really mean? And why does this not show up on our graph? Here's where imaginary numbers come into play. So I, the imaginary number unit, is equal to the square root of negative 1. We need to find where I can fit on our number line. And as strange as this might sound, we can do this by redefining multiplication. So let's redefine multiplication. When we multiply two numbers, we are stretching the first number by the magnitude of the second number. And if the second number is negative, we flip the first number 180 degrees counterclockwise on our number line. Let's look at these examples. 1 times 3 is 3, and we start on 1. We stretch our number line by a factor of 3 so that the dot is now on 3. For the second one, 2 times negative half is equal to negative 1. So we start our dot on 2, and then we stretch our graph by a factor of 1/2. So now our dot is on 1, and now we flip the dot 180 degrees counterclockwise, so now the dot ends at negative 1. To model negative 2 squared, or negative 2 times negative 2 is equal to 4, we need to start our dot at negative 2. Then we stretch our number line in the same direction by a factor of 2, so that our dot ends up at negative 4, and then because the second number is negative, we flip our dot 180 degrees counterclockwise and we end up at 4. So here's the really interesting part. We know if we want to get from negative 1 to 1 or 1 to negative 1, we must be rotating 180 degrees counterclockwise. So if I squared is a 180 degree rotation counterclockwise, that means I must be half of that rotation. Therefore, I must be a 90 degree counterclockwise rotation. Here is the big takeaway from this video. Imaginary numbers are on a perpendicular dimension to the numbers we are used to on the number line. So going back to a previous question, we can now find the roots. We know that the function has imaginary roots, so we need to extend the x-axis to fit all the imaginary numbers. We just need to replace the x-axis with the complex plane with the real number and the imaginary axes. There's just one problem. Although the above graph is three-dimensional, functions in which you can plug in complex numbers have complex outputs. So that means we need to replace the y-axis also with the complex plane, and this is a problem. Because we live in a 3D world, we physically cannot make a four-dimensional graph. Nevertheless, this hasn't stopped mathematicians from trying. If you ever want to see a 4D graph created in a 3D setting, just search up visualizing a complex function. So let's go back to our original question. Is I greater than or less than 0? So I hope you now realize how imaginary numbers are really on another dimension from real numbers. So you can't really make a comparison between imaginary numbers and 0 unless you make the question more specific.